want to do 1.10.3, Algebra 2, Semester 2, Graphing Rational Functions. If you remember from earlier in this unit, there we go. We had to find when the rational expression was undefined and when it was zero. So we're going to actually do both. So the denominator will tell us when they are undefined. So we're going to go ahead and take the denominator, set it equal to 0. Each piece, x plus 3 equals 0. So I'm going to say x equals negative 3 is one of my undefineds. Or vertical asymptotes as we just did in 1.9, right? So whatever makes a rational expression undefined gives us a vertical asymptote on the graph. Then we have x plus 4. I'm going to skip some steps. It's going to be x equals negative 4. It ends up being opposite. All right, so these are my two vertical asymptotes. Coming over here, I'm going to make the rational expression equal to 0, we have an x plus 1. So I'm going to say this is an x equals negative 1. X minus 2, x equals 2. All right, so, and we did this earlier in the section. So I went quick, but earlier in this unit we did this. You made the rational expression equal to 0 by looking at the numerator and setting it equal to 0. And then we made the rational expression undefined by setting the denominator equal to 0. And what this does for us, graphically, is I know that this graph at negative 1 is going to cross, the graph will cross at negative 1. And it will also cross at 2. And then I also know that there is a vertical asymptote at x equals negative 3 and at x equals negative 4. Now this doesn't tell me what the rest of the graph would be. That we would need to plug in some values to figure out other points so we can sketch the graph, but we were able to identify two zeros, which would be taking the numerator and setting equal to 0. And then we were able to identify two vertical asymptotes by taking the denominator, setting it equal to 0. Doing that again, I'm going to go ahead this time and we'll still make this my undefined, then we'll make this my equal to 0. I'm going to go ahead and draw my graph. I'm going to do this one a little bit differently to show you that shortcut, save time type stuff. So I'm going to go to the green. Now I know I'm going to have x plus 1. That tells me I'm going to have an a 0 where the graph crosses the x-axis at x equals negative 1. The x minus 4 is going to be a plus 4, and that will also be a 0, so where the graph crosses the x-axis. Then I need to go and do my denominator. So my first expression is this 4x. So that means x equals 0. So I have a vertical asymptote on the y-axis, x equals 0. Then we have x minus 1. So that'll be x plus 1. So that's a positive 1. So I also have a vertical asymptote here at positive 1. So I was able to identify two zeros and two vertical asymptotes, and I plotted them. Again, we will need more information to actually sketch the graph, but giving us zeros, which is the numerator, and undefined, which would be vertical asymptotes, the denominator, allows us to quickly sketch. Now in this scenario, we would be able to identify, we have three vertical asymptotes, and we can see that on the graph. Right, they're denoted by the red, and that's how it's going to be on apex. So I have one at negative 2 and negative 3. So I know it's going to be x plus 2, x plus 3. And over here we have a positive 1, so that's going to be an x minus 1. So these three factors represent the three asymptotes. And then we also are going to have it crosses the x-axis right here, and that looks like at negative 1. So I'm going to have an x plus 1. And this would be an example of what could possibly be the equation for this graph. Identify where the three asymptotes were at -2, or sit -3, -2, and +1, and that created factors. So I know that this is x equals -2, just rewritten. X equals -3, put it on the same side. X equals +1, put it on the same side. So these three would give us these three vertical asymptotes, and then it crosses here, crosses the x-axis right there at -1, well, x plus 1.